Hello everyone, my name is Büşra Hayat. I am a master degree student at Genetic and Bioengineering Department in Giresun University. Today I am going to present one of my study titled as Activity of Polyphenol Oxidase from Peel and Pulp of Ripe and Unripe Anamur Banana. In this study, first of all, I am going to introduce the polyphenol oxidase enzyme, its properties and problems caused by polyphenol oxidase enzyme in fruits. After mentioning the main objectives, I will give brief information about the materials and methods used in the study. Then I will share results of the study with you, and finally I will conclude my presentation. Enzymatic browning is caused by damage during transportation or processing of fruits and vegetables, or by exposing the cut slice surfaces of these products to air or time after freezing. Enzymatic browning deteriorates the appearance of the products, causing unwanted color, odor, and taste formation, and significant losses in the nutritional value of the products. This affects the acceptability of the products by the consumer and causes economic losses. So, for the commercialization, it is very important to maintain original-like appearances. Browning reactions seen in fruits and vegetables occur as a result of the reaction of polyphenol oxidase enzyme with phenolic compounds. The polyphenol oxidase enzyme is a member of the oxidoreductase class. This enzyme is a copper-containing medulla enzyme and can catalyze to different reactions in the presence of oxygen. They are hydroxylation and oxidation reaction. Banana fruits have a very important place in human nutrition in terms of health because they contain polyphenolic compounds, essential elements, and vitamins. With the understanding of the importance of banana in human health in Turkey, there has been increase in its consumption. Enzymatic browning caused by the PPO enzyme also occurs in banana fruits. This biochemical process that occurs during the ripening period of the banana is one of the important factors that affects the shelf life of the fruit. The enzymatic browning that occurs during the ripening period in bananas can be seen in the picture. The objectives of this study to separate and examine the activity of PPO enzyme found in the peel and pulp parts of unripe and ripe Anamur banana, to develop continuous enzyme activity measurement system for repeat, proper, and reliable data collection, to investigate the quantitative distribution of PPO enzyme in the peel and pulp parts of Anamur banana, to reveal the change in PPO enzyme activity during the ripening period of Anamur banana. Materials. In the study, pulp and peel of ripe and unripe Anamur banana sample were used. The unripe banana sample was supplied from the commercial establishment and stored at -25 centigrade degree before the study. The fresh and ripe banana sample was purchased from the local market. Procatechol was used as a substrate for PPO activity. Bovine serum albumin was used as a standard in Lowry method for protein determination. Methods. Unripe and ripe banana peels were separated from their pulp. The sample taken from the peel and pulp were homogenized with phosphate buffer solution in a blender. The extract were passed through 4-layer cheesecloth. The extract were then centrifuged and the supernatant was used as crude enzyme solution to estimate PPO activity. In a continuous monitoring system, a jacketed reaction chamber was connected to the flow cell placed in the spectrophotometer by polypropylene tubing and a peristaltic pump. Serial concentration of procatechol were used as a substrate in the jacketed reaction chamber. Then 150 microliter of create enzyme solution was added to the substrate. The solution in the chamber was continuously passed through a flow cell. Absorbance values were recorded at 415 nanometer every 30 seconds for 20 minutes. PPO activity kinetics parameters Km and Vmax were calculated by Lineweaver-Burk linearization. Below are the Michaelis-Menten and Lineweaver-Burk plots and equation. Michaelis-Menten plots give the relationship between reaction rate and substrate concentration in an enzyme-catalyzed reaction. The Lineweber plot is a linear form of the Michaelis-Menten equation. Result and discussion. Enzyme activity was calculated from the graphs obtained when the absorbance values against time were read in the spectrophotometer. Michaelis-Menten and Lineweber plots from the enzyme activities corresponding to the substrate concentration of this sample are provided on the next slide. Unripe banana peel sample result. Michaelis-Menten plot and Lineweber plot are given below respectively. The first graph gives the enzyme activity of the sample against different concentration of precatechal substrate. Depending on these values, Km approx 8.6 millimolar and Vmax approx 0.003 absorbance per milliliter seconds, and unripe banana peel sample result. For the measurement of enzyme activity in unripe banana peel samples, the absorbance reading at 415 nanometer in the spectrophotometer was negative. No increase in absorbance was observed. This result indicated that there is little or no PPO enzyme in unripe banana peel. For the ripe banana pulp sample, Km was found to be approx 12.5 millimolar and Vmax approx 0.007 absorbance per milliliter second. For the ripe banana peel sample, Km was found to be approx 29.4 millimolar and Vmax 0.004 absorbance per milliliter seconds. Total protein determination result. Calibration curve graph prepared with BSA standard was used in protein determination. The total protein amounts calculated for each of the banana samples are graphically given below. Vmax and specific activity values increase with maturation. Specific activity was calculated according to the protein content in PPO extract. The Km, Vmax, and PPO specific activity result of the banana samples are given in the table. Conclusion: PPO enzyme activity was detected in all samples except for the unripe enamel banana peel sample. It was determined that the PPO specific activity and Vmax increased with ripening in banana pulp. It was determined that the amount of protein in the pulp was higher in the unripe enamel banana and the amount of protein in the peel was higher in the ripe enamel banana. The continuous flow cell system we developed for our study was used effectively. Thanks to this system, continuous data collection was carried out. Thank you for listening to my presentation.